In this lecture, we'll be solving linear equations that contain multiple fractions. To begin with, we're simply going to solve the equations by keeping and dealing with the fractions. We're going to perform the same steps that we have been. Later in this lecture, I'll show you how to eliminate the fractions in the equation by multiplying through by the least common denominator. Our first equation, we want to solve y minus 2/3 equals 5/12. We want to get the y all by itself. Right now, we have a constant on the same side of the equation as the variable term. We need to eliminate this minus 2/3. To do that, we're going to perform the opposite operation, and we're going to add 2/3 to both sides. On the left, the 2/3 are going to cancel out, leaving us with just y, but now on the right, we need to perform addition between two fractions. I prefer a horizontal format when adding fractions, so I'm going to rewrite 5/12 plus 2/3. When adding fractions, we must have a common denominator. The common denominator between 12 and 3 will be 12. We need to get new numerators to go along with our common denominator. So we ask ourselves, well, what did I multiply 12 by to get 12? 1. I'm going to multiply the numerator by that same number to give me my new numerator, 5/12. We'll do the same thing with the 2/3. We ask ourselves, what did we multiply 3 by to get 12? We multiply by 4. I'm going to multiply the numerator by that same number. I get a new numerator of 8. Now that I have two fractions with a common denominator, I can go ahead and add my numerators together and put it over my common denominator. 5 plus 8 is 13 over 12. We always want to try to simplify our fraction. Simplifying the fraction does not mean converting it to a mixed number. We do not want to write mixed numbers in algebra. Only if we had an application problem would that be appropriate. There's not a common factor in the numerator and denominator. This does not simplify. We have a final answer of y is equal to 13/12. In our next example, we see that all of our variable terms are collected on the left side and all of our constant terms are collected on the right side. However, our variable term is not alone on the left side. It's currently being multiplied by 5/7. To eliminate that multiplication by 5/7, we're going to perform the opposite operation and we're going to divide by 5/7 on both sides. On the left, the 5/7 cancel out, leaving me with just b, but now on the right, we're going to have to perform some division. I'm going to do that over on the side. We have 25 divided by 5/7. When dividing fractions, we multiply by the reciprocal of the second fraction. This becomes 25, and I'm going to put that over 1, times the reciprocal of 5/7, which is 7/5. When multiplying fractions, we can either multiply straight across and then simplify, or we have the option of simplifying first any numerator with any denominator. I see that 25 and 5 are both divisible by 5, so I'm going to go ahead and do that simplification first. 5 goes into 25 5 times. 5 goes into 5 1 time. Now, when I multiply straight across, I get 35 over 1, or simply 35. That gives us a solution of b equals 35. I would use the technique that I've just demonstrated on these first two examples if I had these problems. I would not be inclined to eliminate the fractions by multiplying by the LCD because there was only one move to make. But let's take a look at some more complicated equations involving fractions. It is a legal mathematical move for us to eliminate the fractions in an equation by multiplying every term in the equation by the least common denominator of all the terms. Notice that I have a constant of 2 that is not a fraction. The first thing I would do is I would make that a fraction by putting it over 1. We want to identify the least common denominator between all of our denominators, 8, 4, and 1. Our least common denominator is 8. We're going to multiply each term of our equation by this least common denominator. We'll have 8 over 1 times y over 8 plus 8 over 1 times 3/4 equals 8 over 1 times 2 over 1. The whole point of multiplying by the least common denominator is to eliminate all of the denominators. We want to simplify first. Since we're performing multiplication, we can do that. We want to simplify all the denominators to be 1s. So notice 8 and 8 are both divisible by 8. So 8 goes in there 1 time. 8 goes in here 1 time. Multiplying straight across, that's going to give me 1y over 1, which is simply y. In our next pair, I see that 8 and 4 are both divisible by 4. 4 goes into 8 2 times. 4 goes into 4 1 time. Multiplying straight across, now I have 2 times 3, which is 6 over 1, or just 6. On the right side, both of my denominators are already 1. There's nothing to simplify first. Multiplying straight across, I'm going to get 16 over 1, or simply 16. Now I have an equation that contains no fractions, and I can solve as normal. All of my variable terms are collected on the left side, which means that my constant terms need to be moved to the right side. To eliminate that plus 6, I'm going to perform the opposite operation, and I'm going to subtract 6 from both sides. I end up with y is equal to positive 10. In our next example, we have 3 terms. I notice that one term is not a fraction, so the first thing I would do is make that term a fraction by putting it over 1. I would like to eliminate the fractions in this equation by multiplying by the LCD. So we need to identify the least common denominator between 5, 1, and 5. Our LCD is 5. So I'm going to multiply each one of my terms by 5 over 1 to eliminate the denominators. So we're going to have 5 over 1 times x over 5 minus 5 over 1 times x over 1 equals 5 over 1 times 1/5. The whole point of doing this is to eliminate the denominators, so we should be simplifying first and canceling out all of the denominators. 5 goes into 5 one time, 5 goes into 5 one time. Multiplying straight across, I'm going to get x over 1, or simply x. In my next pair, the denominators are both already 1. There's nothing to simplify. We multiply straight across. We get 5x over 1, or 5x. On the right side of our equation, I see that 5 and 5 are both divisible by 5. So 5 goes into 5 one time, 5 goes into 5 one time. I multiply straight across. I get 1 over 1, or just 1. Now I have an equation with no fractions in it that I can solve as normal. Notice that we have like terms on the left side that can be combined. X minus 5x gives me negative 4x equal to 1. All my variable terms are on the left side. All of my constant terms are on the right side. Now I need to get the variable term all by itself by eliminating the coefficient. To eliminate multiplication by negative 4, I'm going to perform the opposite operation, and I'm going to divide both sides by negative 4. On the right, my negative 4's cancel out, leaving me with 1x. On the right, I asked myself, well, does 4 divide into 1? No, it doesn't. That tells me that my answer is going to be a fraction. Now I just need to simplify that fraction if possible. 1/4 is already a simplified fraction, so my answer is x equals negative 1/4. In our last example, not only do we have a fraction, but we have parentheses. Following the steps that I outlined in the previous lecture, we want to start by distributing. 3 times x is 3x. 3 times a positive 2 is plus 6 over 5 equals 3x plus 6. At this point, we want to eliminate the fractions in the equation. I recommend doing some manipulation to the left side. Using our rules for adding fractions backwards, we can rewrite the left-hand side as 3x over 5 plus 6 over 5. Typically, we don't go this direction. We've in the past had common denominators and then actually added the numerators and put it over that common denominator. However, we can use that rule backwards to split it up into two fractions, equal to 3x over 1 plus 6 over 1. Now that we have our equation written in this form, we want to eliminate the denominators by multiplying each term by our LCD. The least common denominator between 5, 5, 1, and 1 is 5. I'm going to multiply each of these terms by 5 over 1. We'll have 5 over 1 times 3x over 5 plus 5 over 1 times 6 over 5 equals 5 over 1 times 3x over 1 plus 5 over 1 times 6 over 1. Now we eliminate our denominators by simplifying. In our first pair, I see that each of these numbers are divisible by 5. 5 goes in once, 5 goes in once. Multiplying straight across, I get 3x over 1, or simply 3x. In our next pair, again, we're divisible by 5. 5 goes in once, 5 goes in once. Multiplying straight across, I get 6 over 1, or simply 6. The first pair on the right side, denominators are already both 1, so there's nothing to simplify. We just multiply straight across, giving us 15x. Same situation with our next pair, so I can multiply straight across and get 30 over 1, or just 30. Now we have an equation with no fractions in it to solve. I've eliminated parentheses, I've eliminated fractions. I check for like terms to combine on each side of the equation. I don't have any. Next, we want to get all of our variable terms on one side of the equation, all of our constant terms on the opposite side of the equation. We notice that we have both variable and constant terms on both sides of the equation. Therefore, we have a choice of which side of the equation we'd like to move the variables to. I'm going to move the variable term that has the smaller coefficient, so I'm going to move the 3x. It's a positive 3x, so I'm going to subtract 3x from both sides. This gives me 6 is equal to 12x plus 30. Now that all of my variable terms are collected on the right, I have to move my constant terms to the left. This is a plus 30, so I'm going to subtract 30 from both sides to move it. 30s cancel out, leaving me with negative 24 is equal to 12x. And then my last step is to eliminate the coefficient of x. To eliminate that multiplication by positive 12, I'm going to divide both sides by positive 12. 12s cancel out, giving me a solution of 12 goes into 24 2 times, so this is going to give me negative 2 is equal to x.